Hello students, this is Dr. Henk. Today we are going to actually talk about a few things regarding our field explorations and field research. Essentially, we'll be talking about how to keep a field journal, how to identify species, and how to estimate biodiversity. You will be actually doing all these things when you are in the field, and you will be actually using a field journal to keep a detailed record of things that you are going to be seeing, and also to keep some records on our activities and things like that. And when we are out there, we will be seeing tons of species new to us, so we should know how to identify them, at least a fraction of them. And also finally we'll be doing some field research to estimate biodiversity between three sites, and then we'll do a comparison. Okay, so first of all, let me remind you the list of material that you need. The first one is your field journal, and I would highly recommend you to buy Right in the Rain brand, because we are going to a rainforest, right? So there will be some heavy rains, so you need something that is durable and something that you can actually use, something waterproof. So this book will serve the purpose. And also please make sure that you are gonna bring a bunch of pencils. No pens please. A pair of binoculars is a must, because when you are in a rainforest you will hear lots of creatures, and most of them are actually calling from a distance, so you need to have a way to actually look at them and to get a closer view. So that's why you need a pair of binoculars. And we'll be actually touching some stuff, so you may not comfortable touching them without gloves, so please pack a pair of cheap gloves. And also pack several specimen containers. Ziploc bags would be just fine. Once you find a tarantula, right, and then you are supposed to just grab it with your own hand and put it in the specimen container, so we can have a closer look. And also we need a basic calculator. Just grab something cheap, because we are going to be actually using some biodiversity indices to estimate biodiversity. And we'll be using bunch of field guides, and I have already packed bunch of field guides for birds, for reptiles, for amphibians. So we'll be using those field guides to identify species. Okay, so let me remind our field rules and expectations very briefly. Number one, keep talking to minimum, right? This is very important, because we are going to the Amazon to see things, to see these amazing creatures. And if you make some loud noises, we may not get any chance to see them. Number two, so when we are traveling with our guides, so please pay attention and listen to them very carefully. I think it's going to make all of our lives easier. Okay, so the next one, if you see something really cool, and don't yell at the rest of the group. So if you do that, again, that distraction will actually may actually cause that animal to leave the site immediately. And also don't point at something suddenly, so these quick movements can actually be very distractive to those animals. So maybe let's think about using some kind of a non-distractive way to inform other people about these cool creatures, and we'll come up with something when we are in the field. And also we'll be actually traveling through very narrow paths, and sometimes there's no paths, so let's try to walk in a line when it's possible. More rules and expectations. If you have any questions, try to save it, because we are going to be actually traveling in a line for the most part, right? And we have to keep moving. and we have to maximize our time in the field to find new things and to identify things and to explore things. So if we chat in the field, we are just wasting our time. We will have some designated times to discuss about various things, but if you have like a sudden question, write it down on your field notebook, and we'll have some discussion sessions, and also we'll have debriefing sessions during every evening. Okay, so you may remember that your field notebook is going to be about 15% of your overall grade. So make sure to add content. So entries, questions, sketches, species lists, and we'll discuss more about this in a minute. And I hope all of you guys will be bringing a nice camera, because this is a lifetime opportunity to be in Amazon, so you must take pictures. So if it is the case, I'm pretty sure that we have about 15 people, so they all want to take pictures. So let's take turns. And you must have your binoculars, field notebook, and pencils all the times when you are in the field, because you never know when you need it. You must have it. More importantly, be enthusiastic and try to enjoy every moment and learn from it. And this may be the only opportunity for us to be in Amazon, so let's try to take the most out of it. Okay, so let's talk a little bit more about field journaling, and I would like to start with the scientific method. And I'm pretty sure that you all have a basic understanding of scientific method, and it has several steps. And as you can see in this flow chart, the scientific method actually starts with observations, and sometimes we have explanations for these observations, sometimes we don't have any observations. So when we don't have an explanation, so then we'll come up with some questions. So the questioning is the second step, and sometimes you have the answer for these questions, sometimes you don't. When you don't have an answer for these questions based on observations, that's the beginning of a new adventure. Then you'll come up with a hypothesis. So basically a hypothesis is an educated guess to answer your question, and then we'll come up with some predictions following that particular hypothesis, and then you can actually test hypothesis. When you are testing hypothesis, you have to collect some data, and then you will do the data analysis. So the thing that I really want to emphasize is the importance of observations. The scientific method starts with observations, and also doing more observation in a more organized manner is one of the classical methods of hypothesis testing. Careful observations is the first step of ecological investigations, and if you really think about it, it is a skill. And think about hunter, so they are very keen observers, but for the most part we often we take it for granted. If you are a good observer, you can be a good ecologist or a naturalist, and you can be a good observer with practice and patience. So we are going to do some practicing, especially with this class. Observation is the key when you are in the field, so you have to keep your eyes and ears open all the times. The goal is to actually understand patterns and movements in the nature. And as we have discussed earlier, these observations will lead to questions, and these questions may actually lead to great discoveries. And if you remember, most of the Amazon is still undiscovered. I'm pretty sure that we'll be stumbled upon some brand new species. We may not identify those, but let's be ready. And taking field notes is an essential element in converting your observations into a written record. So field notes will actually add a permanent record summarizing your observations. And also, some people argue that they can remember everything, but let's don't risk our observations, and I don't trust my memory 100%. So that's why we need to take field notes. If you have a field note, there's a less chance for distorted information. And also, it's a very simple and a fast way to summarize and keep a complete record of your observations. And especially when it comes to ecology and conservation biology, field journal is the nucleus of your record. And typically you do it as you do things in the field, or you take a break at the end of the day and just summarize everything. And I would encourage you to do both. And typically we would include the most important observations and activities in these field notebooks. So what are the essential components of a field note? Date and time, it's a must. Any field note without a date and time and also a location is useless. When you are writing down the location, try to be as specific as possible, but at the same time, when you are in the Amazon, you will be limited, right? And the weather is another important element, because for the most part, the species that we are going to be observing and also their activities are dependent on the weather. And habitat and vegetation is another key element, because each habitat supports a unique group of organisms. And under general commentary, you can actually do a lot of things, and we'll discuss more about it. And one of the key elements of field notes is species observed and abundance. Abundance is how many of each species. And another way to summarize things is sketching. And let's elaborate on these. So date and time. So you must record the date and time at the beginning of each session. So we may actually do some birding in the morning. So you will start your field notebook in the morning with date and time. And again, we may actually do an afternoon wildlife exploration trip. So then you are going to be actually using the field notebook again, and please write the date and time again. So although we have used the field notebook twice, make sure that you are going to specify the date and time separately. Locality and route, so that's very important. And again, any field note without the location is useless. And sometimes when we go through some museum specimens, some specimens have labels. They have the date, they have the time, but they don't have the location. Those specimens or those information is useless. There's no point of recording things without a specific locality. And when you are describing the locality, you can think about highway numbers, very prominent landmarks, and mileage markers and things like that, because you have to be very specific when you are reporting the locality. And if you are dealing with like a small area, and if you want to emphasize some landmarks, I would highly recommend you to actually sketch a very brief map. And you don't need to think about proportions or scales at this moment, but a small sketch or a map would actually helpful when you are trying to relocate the same location again. And as I mentioned before, weather is another key element, because the weather drives the activity of most organisms. And you can report temperature, precipitation, wind and cloud cover, as much as possible. And again, the fourth element, habitat. Habitat is the key for different communities. And first, you can actually describe your habitat based on the larger category. So it may be a grassland, it may be a rainforest, it may be a riverbank. And also, if you have means to record flow, visibility, things like that, make sure that you are going to add those information. And also, vegetation structure is very important when you are describing a locality or a habitat in a rainforest, because we know that there are some distinct layers of vegetation and they have very specific structure and the distribution. So make sure that you are going to add some information about those elements of the habitat. Okay, so general commentary. This is like the you basically have a lot of flexibility here. So if you think if something is important for your field note, then add it. Things like what are the objectives of the day, and then you can also make a note whether you have actually achieved that objective of the day and the activities that we have done. Important observations. Maybe we'll see a jaguar, so that's going to be a very exciting sighting of the day. And also make sure that you are going to add some information about your field companions. If you use any equipment, make sure that you are going to add those information. And if you collect some data, write down your data. We may actually set some traps and we may leave them overnight, so then you need to relocate them. So you need to have some information about your number of traps and the location of traps, things like that. The species observed or collected, and you may actually collect lots of information about the sites and animals and their behavior just by talking to local people and guides. So make sure that you are gonna record as much information as possible on your field notebook. Species lists and abundance is the next element, and I personally allocate a lot of space in my field notebooks for this, because I'm a lister. I like to list species, and I would expect you to do the same, because it's one of the critical elements of ecology and conservation biology. So you can use common names. Sometimes we may not identify the species in the field, so in that case, let's take some pictures or let's take some sketches, and then we can compare and identify them later and add to the list during the evening sessions. With most of the taxa, you can use the common name, but with some we may have to use the scientific name. And it's always nice to have some extra information. So I'd rather write I've seen 15 urchins rather than just listing the name of that bird. And also we may actually encounter some mixed species feeding flocks. So these are actually groups of birds, multiple species traveling together, and they feed in various layers of the rainforest. So if we encounter some of these, make sure that you are going to record the sequence of species and the foraging height, and also you may notice some alarm calls, because that's a really cool strategy of birds to avoid predation and maximize their feeding efficiency. So some species actually feed on the canopies, some in the middle layers, and some on ground, and some will be vigilant when the others are actually feeding, and sometimes small mammals will actually join these groups. So it would be really cool if we can actually find one of these flocks. Sketching. And I know nowadays we are very hesitant to sketch, but that's one of the best ways to collect lots of data within a very short amount of time. So we can actually sketch to provide information about our habitats, our localities, and also we can do some sketching to support species identification. So when you are sketching, make sure that you are going to focus on shape, size, colors and behavior, and then we can actually use these sketches to identify species later by comparing with a field guide. Do you recognize this field notebook? Yeah, it's pretty clear. Charles Darwin's field notebook, right? And I'm positive that you know who is Charles Darwin. And he wrote this monumental book on the origin of species, and there's only one figure in that entire book, and this is it. And this is the moment that he actually conceived the idea of evolution by natural selection. So he just sketched it right away. And if he actually took time to write this down, he may actually lose some of the critical elements of that idea. So he sketched it right away. And if you look at some of the other pages of his field notes, it's like this. There's lots and lots of words. But what do you think? What is the most efficient way of collecting lots of data or lots of information within a very short period of time? Sketching or writing it down? Maybe both. But with a picture, you can actually capture lots of information very fast. So that's why we need to do some sketching. This is a couple pages of a field notebook from a geologist, and you can see there's some text, there's a picture, and also there's some sketching. So you can actually capture lots of information through sketching. This is a field note from another person, and this time it's an ecologist, and that person took some nice field notes of this bird, and then he later identified it as a whimbrel. So you can see date and time, some sketching to illustrate the features of that particular bird, and also he attempted to write down the call of the bird, and 3 whimbrels seen, that's the abundance. And these are more field notes. So you can see some lists, you can see some paragraphs, you can see some sketches, and we all should do some sketching in the field. It's hard at the very beginning, but once you spend some time sketching, I guarantee that you'll actually enjoy it. And this is a field notebook from a hardcore birder, and you see that he took lots of information about this very rare petrel, and finally he actually identified it as Swinhoe's petrel. And I'm not expecting you to take field notes in this caliber. If you can, that would be wonderful. If not, that's okay, but let's try our best to do some good field sketching and field journaling. Okay, we are moving to the next section, how to identify species. So when you are in the Amazon, you will be surrounded by hundreds, if not thousands, of species, and doing some species identification is a critical element of this class, because we are trying to learn about these animals and their behavior, their adaptations, things like that. Without a name, it's really hard to do that. So typically there are several ways of species identification. The easiest is somebody actually giving a name to that particular organism, right? So typically field guides or experts would do it for you. So that's one option, but I don't know whether we'll have that opportunity. We may. The second one is you can be familiar with common species in the area. Before you go to a location, grab some information and be familiar with expected species, and once you see it in the field, you can actually recognize it. And the other method would be using field guides. I think we are going to be using a bunch of field guides to identify species, because we are going to a biodiversity hotspot. There's going to be thousands of species, and almost all of them are going to be new to us, so we should actually use some field guides. So basically you can take pictures, and then later we can actually compare those pictures with our field guides and identify species, or you can do some sketching in the field, and then you can actually use those sketches to identify species. That's the point. And in this picture you can see some pictures from a field guide. So in this case you can see color plates, and also there's some corresponding information in the opposite page with some distribution maps and some field identification features, things like that. So we are going to hone some of the skills that we can use to identify birds when we are in the field. So I picked birds because it's a well-established discipline or a hobby. So there's so many birders in the world, and it's a very colorful group of organisms, and they are everywhere. So let's learn how to identify birds, and then we are going to be actually using this the list of same skills to identify other organisms, mammals, reptiles, amphibians, and things like that. So when it comes to bird identification, size and shape is the most critical single factor. And then you can move to color patterns, habitats, and behavior. And you can narrow down the species list or possible species by habitat, and also some species have very unique behavior. So just by observing that behavior you can identify the species. And color pattern should be the last one to identify species, but we are going to be actually using it a lot. So please watch the 4 videos that I have uploaded into Canvas, and that series will actually explain the importance of these elements in identification of birds, and it will actually explain how to use these elements in identification of birds. And in this picture you can see silhouettes of bunch of birds. So once you have some experience, you can actually identify the species. I'm not talking about the group, like the species, just by looking at the silhouette. But unfortunately, all of the birds that we are going to be seeing in Ecuador will be brand new to us. So we may need to rely a little bit more on color patterns and their behavior and habitats when identifying species. And sometimes when you are sketching or when you are trying to describe a bird, you may need to have a very basic idea of the various parts of the bird. For an example, you may see a bird with a white crown and a brown body. So you should know what is the crown. And sometimes you may find a bird with white wing coverts. So then you should know what are those white wing coverts, and you can actually do a better job with sketching if you have a very basic idea of these parts of a bird. Okay, so how many of you guys have seen this bird? And what are the distinguishing features of this bird? So this bird looks like a sparrow, right? And typically when you are describing the size and the shape, and the easiest way to do it is to compare it with a very common known bird. So in this case, this bird has a short conical bill and a relatively short tail, and it's a very bulky bird, and it's brown. So you can this is actually a white-throated sparrow, and you can see the white throat right here. and it has a white supercilium, eyebrow, and also it has some yellow patches in front of the head, and the rest of the body is hard to describe, right? It's just brown. This is a very common bird, typically in the winter time in Virginia. So basically I want to emphasize the shape and the color and the relative size of birds, and this is a different one, right? And the shape is completely different. It has a short conical bill, short tail again, and a very bright plumage. And do you recognize this bird? This is a male eastern bluebird. So in this case we can clearly use the color patterns to distinguish the bird, but sometimes the color is going to be very challenging because it's a product of various angles of lighting. And I would love to see this bird when we are out there horsing, and it's a very unique bird. And how would you explain this bird? It's a large, bulky bird, overall brown, and it has a crest, red eyes, relatively short conical bill, and bare facial skin, and it's blue. So the easiest way to actually describe something like this is to just sketch it. This is another bird. Sometimes we have to actually identify birds when they are actually in flight. So this is a turkey vulture, and we may actually see turkey vultures and several other species of vultures in Ecuador. So this is what you do. So if you can take a picture, that's great. If you have some extra time, try to do at least some sketching. Sketching will actually force you to look at details, and that details are necessary for correct species identification. So in this case you can see there's a sketch, and also you can use these arrows to indicate various field marks, color patterns, things like that. And when you are reporting the size, you can compare it with a known bird. So you can say it's a bird about the size of a sparrow, or something between a crow and a sparrow, larger than Canada geese. So just use those most familiar species of birds. So with that, I'm going to wrap up the species identification, and then we are going to jump into the next section, how to estimate biodiversity. So our goal is to actually study and compare biodiversity between 3 sites. So we'll collect some data from a virgin forest, and a disturbed site, and a secondary growth, and then we'll study the most biodiverse location among these 3, and then we can actually do some comparisons among sites. Okay, so before we talk about biodiversity, I have a question for you guys. So which sample is the most diverse? I have 2 samples, sample A and sample B. What is your answer? Which sample is the most diverse, A or B? You may say it's sample A, right? Because there's 3 species in this sample. We have this dark butterfly, we have a dragonfly, and we have a ladybug. So 3 species versus only 2 species in sample B. So that's one way of actually estimating biodiversity. So number of species, right? But think about the number of individuals of each species. So imagine that you are going to sample a site, and you are going to randomly sample species one at a time. So what is the probability of getting this butterfly? So there's 6 of these guys, and there's 8 total. So that's 75%. So at 75% of the times you'll just keep getting this butterfly, and if you don't do enough sampling, you may conclude that there's only one species in that site, because you may completely miss these two rare species. In contrast, if you go to the sample site B, there's two species, but they both have equal probability of capture. So if you capture the butterfly for the first time, you have a 50% chance of getting the ant as the second species. So with even less sampling, your probability of capturing all the species is pretty high compared to the sample A. So that's the tricky part. So when you are sampling site for biodiversity, you must use two elements. The first one is number of species, and also you must combine that information with number of individuals of each species. So biodiversity is a complex phenomenon, and it's really hard to measure it because of this complexity, and that's why we came up with some ways to combine these two elements, number of species, and typically we call it species richness, and also the relative abundance of species, that is evenness. And let's see how you can actually combine both of these elements to do a better job when measuring biodiversity. Ecologists have actually devised a bunch of biodiversity indices. One of the most famous one is Shannon index, H prime, of species diversity. And as you can see, it's a very simple formula. H prime equals minus sum of pi into ln pi. And we are going to be actually doing a little exercise to practice the application of these equations in a minute, but I want to emphasize this is a very simple equation. So you can see this pi. So pi is the proportion of a given species. So basically it's really easy to estimate a proportion. So if you go back to our previous example, so there was 6 butterflies, 1 dragonfly, and 1 ladybug. So what is the proportion of butterflies? That's going to be 6 out of 8, 75%. And that's what we are going to be actually using to replace this pi, and then we can actually estimate the Shannon index for a given site. And also when you get a larger H prime, that says that the species diversity is pretty high. So there's a directly proportional relationship between H prime and the species diversity. The second index that we are going to be using is the Simpson's index, and we can actually use it to estimate the dominance. So when there's dominance, when there's more dominance, the diversity is pretty high, pretty low. Think about the same sample A. 6 out of 8 individuals are butterflies. So that particular sample is dominated by just one species. When the dominance is high, the diversity is low. With this index, Simpson's index, we can actually use the same proportion to estimate the dominance. And the only difference is when the D is large, the species diversity is low. It's a inversely proportional relationship. Okay, so let's practice this. Let's see how we are going to apply the H prime and D to estimate the diversity of a given site. And I have 2 sites, site A and site B, and I'm pretty sure that you guys are very thrilled to handle some spiders when we are in the field. So let's use some spider examples. So in the site A, we have 3 species of spiders. Do you recognize those 3 species? we have these black wolf spiders, we have a single tarantula, and we also have a single black widow spider. In site B, again we have the same species of black widow, we have 3 tarantulas, and now we have this really cool jumping spider too. So in both sites there's 3 species. If you just use the number of species, both sites are equally biodiverse. But look at the distribution of species. In site A you have 12 black wolf spiders, but only 1 tarantula and 1 black widow spider. So basically the site A is dominated by a single species. So if you remember, when the dominance is high, the diversity should be low, right? In site B we have 5 black widow spiders, 3 tarantulas, and 6 jumping spiders, and there's no dominance in site B. So let's see how we can actually use this information to numerically estimate the biodiversity of a given site. So let me go back to my Excel sheet. So the first thing that you need to do is you need to actually summarize your information in a table like this. So I have the species list. So between both sites we had 4 species, and now I'm trying to actually tabulate the site specific information, and this is the number of species in each site. So in site A we had 12 black wolf spiders, 1 rainbow tarantula, and 1 black widow, but no jumping spiders. Okay, what about site number 2, site B? So let's have a look. So we have 5 black widows, 3 tarantulas, and 6 jumping spiders. So I'm gonna just enter my data. 5, 3, I'm sorry, there's no wolf spiders, right? It's gonna be 0. Rainbow tarantulas, how many black widows? 5, and 6 jumping spiders. And if you remember, so let me type the equations. So the first one is the Shannon-Wynne index, right? So H prime equals minus sum of pi multiplied by ln pi, right? And the second one is Simpson's D to estimate the dominance. D equals sum of pi, okay, let me try to find the cap sign, the square of the pi, right? So if you carefully look at these 2 equations, you need to estimate pi, right, the proportion, and you need ln pi, and also you need pi squared, and that's what I have here. So you guys have to complete an assignment on your own, and basically you are going to be doing this in the mega scale, comparing 5 sites. So make sure that you are going to follow me very carefully. So the first step is to tabulate all your data like this, and this is your raw data, and let me delete this. This is the starting point, right? Okay, so how would you estimate pi? That's a proportion. So the proportion of black wolf spiders is the number of black wolf spiders divided by the total number of organisms in that sample, right? So in this sample we have, let's see, I'm going to take the sum of it. We have 14 individuals in our second sample, and again we have 14 individuals, right? So when you use Excel formulas, you have to start the formula with an equal sign. So now I'm trying to actually estimate the PI, the proportion of black wool spiders. So select that particular cell, equal sign, and then I'm going to click on number 12 and division, and then I'm going to type 14. So basically I'm dividing the number of wool spiders by the total number of individuals in that sample to estimate the proportion. Hit enter. So the proportion is 0.85, right? And now I'm going to actually estimate the PI squared, because I need PI squared to estimate the Simpson's dominance, right? And again, you have already estimated the PI, so it's just squaring it. Equal sign, click multiplication, and click PI again and hit enter. So this is your PI squared. The next step, we need to estimate the natural logarithms of PI, and I'm gonna again use an Excel formula, equal sign. I'm gonna just type ln, and this is the formula to estimate the natural logarithms. And then I'm gonna start parenthesis, and here is my PI, so I'm gonna just click on that particular cell and close the parenthesis and hit enter. So, and it should be a negative value. And finally, now I'm trying to estimate PI into ln PI. So basically this entire part right here, and it should be very easy now because I have already estimated PI and also ln PI. And equal sign, click on PI, multiplication, and ln PI and hit enter. So we just estimated the black wool spider information. Why don't you guys actually do the rest? I bet that you can actually do it. And also there's a trick. So basically you can actually copy paste formulas in Excel. So what am I gonna do is I'm gonna just highlight all of these estimates, and do you see that there's a little black box right here? And right now I have thick crosshairs for my cursor. Once I move this thick crosshairs to this black line, a black box, it'll turn into fine crosshairs. Once you have the fine crosshairs, click it and drag it all the way down to cover the rest of the cells, and it should automatically calculate the rest for you. Okay, so now we have all the data for site A, but we have some these weird stuff, right? What are these nums? So basically we need to get rid of these. These are products of like nonsensical data. There's no natural logarithms of a 0, so that's why we actually got these. So why don't we actually delete these nums? Otherwise it can actually create some issues. Okay, so let me do site B now. So I have the raw data right here, and I'm gonna cheat. I'm gonna just copy paste the formulas and then modify them. Paste special formulas. Okay. Okay, since there's, and I'm gonna actually modify this. Do I need to? No, I don't need to, because the total number of individuals is the same for both sides. And again we've got these nums because the natural logarithms of 0 is nonsensical. And I'm going to extrapolate my formulas. Okay, so now I have all the data that I need all the estimates that I need to estimate H prime and D. And let me delete these two. Okay, we are almost done, but we don't have the final answers yet. So if you look at H prime, right, so we estimated pi into ln pi's for every species, but when you are estimating H prime, you have to get the sum of it, sum of all the species. Likewise, when you are estimating Simpson's D, you are supposed to get the sum of pi squareds of all species. The easiest way to do is just use the auto sum. So highlight your range including the cell that you would expect your answer to be, and hit auto sum, and then I'm going to extrapolate. Okay, now I have some numbers, right? And if you get 1 here, that's a good sign, because the proportions of everything should be equal to 1, right? And let me highlight some cells. Okay, so do you guys make any connections with these highlighted cells and these equations? And let me do the sum for the rest. And I'm going to delete this because we don't need this one. Again, we got a sum of 1 for pi's. That's good, because all the sum of the proportions should be equal to 1. And I'm going to highlight these again. Okay, so do you make the connection? So sum of pi squared, this number, is D, right? So our D for site A is 0.7448, and our dominance value again for site B is 0.3571. So we got a bigger value, 0.74 for site A, and half of it, less than half of it, for site B. And if you remember correct, look at this, site A is dominated by a single individual, single species, so the diversity is low, right? And let's look at this equation now. So H prime equals minus sum of pi into ln pi, and this value is a negative value. So once you multiply this negative value by a -1, it's going to be a positive value, right? And ecologists don't like negative values, so basically we added this minus sign just to convert this to a positive value, and this is your H prime without the minus value, the negative value, and again this is your H prime. Got it? So it's not hard, but you have to follow the sequence. And you have an assignment in Canvas. Basically you are going to be comparing 5 sites using spider diversity information, in addition to Simpson's D and Shannon-Wien index. You are going to be using the number of endemics. The endemic taxa are organisms which are restricted to just one place, and I will actually tell you more information about that assignment, and this is just the primer for that assignment. Okay, so let's go back. Okay, so this is your information, and we just solved H prime and D for both site A and B. And if the H prime is high, the diversity is high. If the D is high, the diversity is low. And if you remember correct, go double check the numbers, and I will post that soon. This site A is dominated by one species, so we've got a relatively low H prime value and high D value, but in site B, 3 species are more or less co-dominated, so we've got a relatively high H prime value and a relatively low D value. With that, let's go to Amazon and let's collect some spiders and between those 3 habitats, and let's try to solve the numbers for H prime and D. Thank you.